The solar system, our home, vast, majestic, peaceful. Think again. Once there was nothing here but a huge, thin cloud of gas. How did we get from this to this?
When we look out there, we're really looking for our own origins, what happened to us.
Piecing together our system's history suggests a wildly chaotic birth.
It's almost like a planetary pinball game.
These are exquisitely violent events.
It's the ultimate survival story. The formation of our solar system. Throughout history, the heavens inspired awe and wonder in human observers. Our ancestors watched the skies with amazement, imagining the power of the bright objects that we now call planets.
The fact is that for as long as there have been people, we've looked at the sky, we've looked at what we see there, we've asked the question, what's the connection between that and us?
The ancients erected standing stones, temples, and pyramids from which to predict cosmic events and to worship the gods in the sky. But the first telescopes revealed a universe unlike anything we could have imagined. We began to see what was really out there. Not gods, but planets, stars, immense clouds of gas. In 1755, Immanuel Kant, German scientist and philosopher, turned his attention to these huge clouds, or nebulae, and in the process, came up with one of the first modern theories of how the solar system formed.
All of these beautiful clouds in interstellar space have turned out to be very important. It's where stars are born, it's where planets form.
Kant's key idea was that nebulae could collapse in and condense into planets and stars. It's known as the nebular theory. 250 years later, Kant's theories still help to explain the birth of our solar system. Today, new observations are revealing how the sun, planets, and moons of our solar system took shape. Scientists, like Professor Jeff Hester, are solving many of the long-standing mysteries of the formation process.
We now have answers to questions that people have asked themselves for as long as there have been people. And it changes the way that we think about ourselves.
Dr. Michelle Thaler is an astronomer working with NASA's Spitzer Space Telescope. It's the fourth and last satellite of NASA's Great Observatory program. And it gives scientists a totally new view of the universe.
What's happening now in astronomy is we're finally seeing the universe as it really is, not just as humans perceive it.
One way to establish how our solar system forms is to watch other distant systems take shape. But if Kant was right, and new solar systems form deep within clouds of interstellar gas, we might never see this happening.
Our own senses, what the human eye can see, turns out not to be the whole story. There's so much more out there that the humans just don't have the capability to see naturally.
Objects emit infrared radiation. Infrared has a longer wavelength than visible light, so is not scattered by dust. Conventional telescopes that use visible light cannot see inside a dusty nebula, but infrared sensors on board Spitzer can. The same principle is used by firefighters.
This room is completely full of smoke. There is no way that you can see with your eyes or with a regular camera what's going on inside. So fire departments use infrared cameras to be able to see people inside a smoke-filled room and actually see the heat of a person's body. This is exactly how Spitzer works. Spitzer actually looks through these giant clouds of smoke and dust to see planets inside, just like these guys can find the people. Visible light is completely blocked by things like smoke and dust, but infrared light is a longer wavelength, and actually it's just sort of a happy coincidence for us that nothing stops it in the chemistry of smoke and dust. I think you really get a sense now that we're able to see where we've never seen before using the Spitzer Space Telescope.
A camera in a smoke-filled room is one thing. A telescope in outer space is quite another. On the ground in 2003, Fowler and her colleagues wait anxiously for Spitzer's first data. At stake is a unique view of the origins of our own solar system.
Literally, no one had ever seen what the universe looks like in that type of light. So at first we were amazed at the beauty. I did not expect Spitzer's images to be as compelling visually to me as they turned out to be. They are beautiful.
But these are not just pretty images. Crucially, by observing distant worlds as they form, we also learn more about the birth of our own system.
One of the privileges of observing star and planet formation is that you're effectively looking back in time. You're looking at what we must have gone through billions of years ago.
What this glimpse back in time reveals is a snapshot of the earliest stages of solar system formation. This is our best ever view inside a nebula's collapse.
We've actually been able to observe with Spitzer the moment where the dust begins to collect together and then get warm, and then finally young stars emerge.
So it turns out, Kant's 250-year-old theory is essentially correct. Our own nebula began its collapse 4.6 billion years ago. It's likely that the nebula had been slowly spinning in space ever since its formation. But as its material collapsed, it began to spin much faster. This is down to the law of physics known as conservation of angular momentum. As the nebula contracts, the same amount of energy is now concentrated in a smaller space. To keep the same momentum, rotation speed must increase. As our nebula began to collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction. But when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos: the explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the Bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, at the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime. And yet the supernova delivers this in less than a day, and then expands for a few months afterwards. As it expands, it's as bright as an entire galaxy. It's as bright as a billion suns.
Extreme nuclear processes within the dying star fuse the elements the star created in life to make heavier elements. As the star explodes, it blasts these into space.
In its death, it creates the essential elements for making planets and life elsewhere. It spews the products of millions of years of nuclear reactions out into the gas in between the stars.
This is the basis for some of the clouds that eventually form new stars. Yet they are spread so thin that it's difficult to know what triggers a cloud like this to collapse. The best way to find out is to examine the material that once made up the cloud. And that means examining the two oldest types of material in the solar system: asteroids and comets. But first, scientists need to bring back a sample from outer space. Comets are relics from the earliest days of the solar system and may hold clues to our origins. But before scientists could study them in depth, they needed samples. In 1981, this man, NASA's Dr. Peter So, started to work on his idea to return comet